Hi everybody! Today we will talk about ionic binding. There are different ways in which particles can be bonded to each other. One of these chemical bonds is the ionic bond. Here, oppositely charged ions are bonded to each other. Let's look at common salt. Elemental sodium has only a single valence electron, or electron in the outer shell, shown here as a dot. Elemental chlorine, on the other hand, has a total of 7 valence electrons. 6 of them are present as paired electrons, in other words, 3 electron pairs, shown here with lines. The 7th electron is unpaired. Let's remember the octet rule. Particles are most stable when they have a fully occupied outer electron shell. This is not the case neither for sodium nor for chlorine. But when the sodium gives up its single electron, the full underlying electron shell is the outer shell, which is why Na+ is more stable. When the chlorine then accepts this electron, it reaches a fully occupied outer shell with 8 valence electrons, which is why Cl-, also called chloride, is the more stable form. This creates a cation and an anion that attract each other. However, the reaction does not take place as shown here. Chlorine is always present as Cl2, in other words, as chlorine gas. However, the simplified mechanism is sufficient for illustration. Okay, so this is what a salt molecule looks like? Yeah, no. Ions do not form molecules in the conventional sense, but lattice structures. Let's look at common salt again as an example. What you see here is a schematic representation of an NaCl-crystal. The gray spheres represent sodium ions and the green spheres represent chloride ions. These ions are arranged in such a way that positively and negatively charged ions always alternate. Thus, the attractive forces between the ions hold the lattice together. Each sodium ion is surrounded by 6 chloride ions, as shown by the corners of the gray octahedron. Above, below, left, right, in front, and behind the sodium ion there is a chloride ion. The same is true for the chloride ions, as you can see from the green octahedron. Chloride ions are also surrounded by 6 sodium ions. This kind of bonding is characteristic for salts in general. Not all salt lattices look the same, and the coordination numbers, that is, which ion is surrounded by how many oppositely charged ions, can also be different. The most important thing is that ionic compounds are always neutral on the outside, meaning there are always equal numbers of positive and negative charges in the crystal. We have already seen this with sodium chloride, or common salt. The ions are in a 1-to-1 ratio. But what about magnesium chloride? The magnesium cation is doubly positively charged, so it takes 2 chloride ions to balance 1 magnesium ion. Accordingly, the ratio in the crystal is 1-to-2. In general, the molecular formula, so NaCl or MgCl2, does not reflect the molecule but shows the proportions in the crystal. This was an overview over ionic binding. If you have questions, suggestions, or tips, leave them down in the comments. If you liked the video, like it and subscribe to my channel. See you in the next one!